Today we are seeing the example on higher order linear differential equation with constant coefficient. Here I will detail you about the three cases of the PI which is involved in this example. Example is solve this quantity with the e raised to the power 2x, x cube and cos 2x. So to the RHS part we are having the exponential function, polynomial of degree 3 as well as the cosine function. So there are three different methods to calculate this PI is there. So we will see that. So first of all, first job is to find out that it is complementary function for this differential equation. So we just add on the given equation, then its auxiliary equation we have to obtain. Auxiliary equation is obtained from this function of d just by replacing the d by m. It is a m square minus 4m plus 4 equals to 0. If you observe it properly, it is nothing but the m minus 2 whole square. Okay, so m minus 2 can be written as m minus 2 into m minus 2. So the roots are, it is 2 2. We can say these are the linear factor we are having. Therefore we can write the roots as plus 2 and plus 2. Then complementary function for the repeated real roots will be c1 plus c2x into e raised to the power this 2 we use here, e to the power 2x. So to one of the constant we multiply by the independent variable while writing the CF, complementary function, c1 plus c2x e raised to the power 2x. For the equal roots we take the constant this way. Clear? Now moving to calculate here, it is what? PI. PI will be given by 1 upon that function of d square minus 4d plus 4 operating over the RHS part of the equation, that is written here. Now I operate this operator over each term. These three terms are here. So तीनों term में हम इसको operate करेंगे. Now if you look at this first term, in the first term we are having e raised to the power, what is it? 2x. Okay. So to solve it, this particular term, I replace the d by, it is what? 2. It is the case whenever we are having exponential term e raised to the power ax, d should be replaced by a. So here a is what? 2. D will be replaced by 2. This is 2. This is 2. We are having. So 2 2 we have written here. Okay, but if you just calculate this, it will be what? 0. But 1 by 0 we are having, so the case fails here. So in this case what we do, I multiply to the left by, what is it? X. X से multiply करेंगे and we take the derivative of this denominator, that will be 2d minus 4. This is 0. This 2d minus 4 we have written. Again applying the case of exponential, I replace the d by what? It is 2. 2 से replace किया, again it is coming to be what? It is 0. अगर 0 फिर से again we do the differentiation and multiply by the x. So I multiply by the x, it will be x square. Take a differentiation of this 2d minus 4, it will be what? Just 2d, just it is what? 2 and it is 0. 2 is here. So it is x square by 2 e to the power 2x. There is no terms of d here. Okay. So this is our now required PI for the first part of the PI, which is here for the exponential function. Now second term we are having what? X cube. उसको भी हम solve करेंगे यहाँ पे simultaneously. For the x cube, whenever we are having a polynomial term, what we do? I take out the lowest degree term outside from the denominator. Okay. What is the lowest degree term here? D square, the second degree, d first degree, 4 d to the power 0. That is the lowest degree. So 4 is the lowest degree that we take outside. Then this will be 1 plus. Divide this by the 4. Divide by this by the 4 because we are taking the 4 outside. Okay, so this will be 1 by 4 outside, 1 plus this quantity. So you have to write down that denominator into 1 plus form. Okay, so 1 plus this function of d. This we take to the up with a negative index, that is to the power minus 1. Now I will expand this term by using the binomial expansion. It is nothing but we can relate this to the 1 plus x to the power minus 1. So we are having the formula 1 plus x to the power minus 1. The formula is what? By the binomial expansion, 1 minus x plus x square minus x cube plus so on. So I will use this formula 1 plus x. You have to go with alternate sign. Okay, just remember. So now I expanded here 1 minus this quantity, then plus square of this quantity, then minus cube of this quantity, plus it goes so on. Then it is what? X cube. Now here x is having the order 3, therefore we are expanding up to the order 3 only. Okay, because for the derivative of this x cube is 0, it will be 0. So that's why we are leaving the further terms. How it is 0? If you just do the differentiation of x cube, that will be coming out to be, what is it? It is 3x square, then the derivative of 3x square, again it is 6x, then the derivative of 6x, it is 6, then the derivative of 6 is what? It is 0. First derivative 3x square, second derivative 6x, third derivative 6, and fourth derivative is what? 0. So therefore we are not considering the further term of to the power 4, we are leaving that term. Then into x cube is written here. Then further I just open the brackets, it will be about 1 plus minus d square by 4, then square this a plus b whole square, a square plus 2 times of ab plus b square, we get this quantity. Then this is a plus b whole cube, the formula is what? A cube plus 3a square b plus 3ab square plus b cube. Okay, so we just open it again, this is written here, and I have told you this is the expansion of what? A plus b whole cube, which is written here. Okay, now after that it is a x cube we are having, and after expanding this one, again I collect the terms of it is what? D square and d cube. So this will be 1 plus d, then there are two terms of a d square, it is a minus 1 by 4 d square and plus d. So minus 1 by 4 plus 1 is what? 3 by 4 d square. Okay, then the terms of d cube we relate, this is what? Minus d cube. Okay, it is a 2 by 4, it is 1 by 2. So minus 1 by 2 d cube, or d cube can, this is the d cube, minus minus get plus d cube. If you do the calculation, you will get 1 by 2 d cube. Now if you see, this is the term of d to the power 4, means fourth derivative, and we have already discussed that fourth derivative of x cube is what? 0. So we leave this term. Again here if you look at this term, this is the d square, again d to the power 4, leaving this term because the derivative will be 0 of x cube. Again here it is d to the power 4 into d, this is d to the power 5, fifth derivative. अगर fourth is 0 है तो fifth भी क्या रहेगा? It is 0. Okay, again here d to the power 6, that is to the power 6, that is sixth derivative, again it is what? 0. So we will not take into account these terms, that is d to the power 4, d to the power 4, d to the power 5 and d to the power 6, because they are 0. Okay, we only take account up to the it is d cube, due to the d cube तक term लेंगे हम, because x is having the power 3. After that I multiply this 1 with the x cube, then take a derivative of d, it is x cube का derivative, that will be what? It is 3x square. D square means second derivative, first is what? 3 square, second will be what? 6x, then of d cube means third derivative of x cube. So first is 3x square, second is 6x, third will be 6, into we are having what? X cube नहीं लिखेगा मैं यहाँ पे, sorry, this x cube we have just multiplied to each term. Then further after getting this one, I have just simplified the quantity, that is 6 by 2 is what? It is 3, then this is 3 by 4 into 6, that is 9 by 2, that we have written. So this is about the solving the pi for polynomial of degree 3. Okay, now the third term is also there, that is of cos 2x, it is cos 2x. So this cos 2x we have written. Then in sin and cos, what we do, whenever we are having it is sin ax or it is cos ax, so that time I replace the d square by what? Minus a square. Okay, so I am replacing the d square by it is minus a square. A is what here? It is 2, then square will be it is what? 4, but we require minus of a square, so it will be a minus 4. So d square will be replaced by minus 4, minus 4d plus 4. This minus 4 plus 4 get cancelled. What is left? Minus 1 upon minus 4d. 1 by d means it is the integration, because d stand for the derivative with respect to dx. So 1 by d will be the integration with respect to dx. So integrating this cos 2x with respect to dx, and that is what we may have, it is a sin 2x by 2. Okay. So this is the integration, simplifying the quantity, we are having that as a minus 1 by sin 2x. So in this way we have obtained the pi for the each term. Okay, हर एक टर्म को हमने सेपरेटली सॉल्व किया हुआ है यहाँ पे, then collectively we have written. Then this is the pi, then complete solution for the problem is given by, it is a combination of complementary function and particular integral. So y is equal to cf plus pi. So the cf we have already calculated, that is there, and the pi just write down, and that gives the complete solution, that is also called as the general solution of a given differential equation. Now this is the equation of the order 2. Therefore in the solution you are seeing there are two arbitrary constants. सो जितना ऑर्डर होता है उतने आर्बिट्रेरी कॉन्स्टेंट्स सॉल्यूशन में होते हैं. दैट शुड बी रिमेंबर. इफ ऑर्डर इज 3 देयर विल बी द 3 आर्बिट्रेरी कॉन्स्टेंट्स. यहाँ पे ऑर्डर 2 है, देयरफॉर हियर इट इज अ 2 आर्बिट्रेरी कॉन्स्टेंट्स आई हियर. ओके, थैंक यू.